pick a date for your presentation and put your name by that date and that'll be your date. If you have not done a research experience, you pick a partner and both of y'all put your name by that date. That's the way we do it in here. Go ahead.
So I'm gonna continue on what we started last week, and dealing with research, you're looking for answering 4 questions: is where, what, how, and why. And we said that the where and what can be translated to monitoring. You want to analyze the environment to find out what is in there and where it is, how much of it. So that's called monitoring. When you monitor the presence of a chemical, regardless if a pollutant or not a pollutant, you can do it with 3 ways: field analysis, like the gentleman was talking about, going and collecting water samples, or you can do lab analytical work, or you can do the so-called biomarkers. So the one type of environmental monitoring is to use biomarkers, which is an indicator in a living organism that would actually tell you if the population has been exposed to chemicals or not. So we use the word biomarkers to evaluate exposure of population. And the population could be humans, or it could be wild animals, or it could be microorganisms, whatever. So biomarker can be applied to all of these different things. I want to begin with saying that we were, at that time, when we started this, we were the first people actually to mention the word biomarkers in analytical work. And we published 2 books, and I was the editor for both of them. This was the biomarker of exposure to pesticides, and the other one, biomarker of exposure to toxic chemical in general. And these were published by the American Chemical Society as a symposium book. So this was the beginning of the biomarker work. And this is an image here. Remember when you take a water sample from, let's say, from a ship channel in Houston, you can actually look at micro creature in there. Like in this case here, we call this phytoplankton. Plankton are any suspended living organisms. They're much bigger than bacteria, but you can use them as an indicator or a biomarker, because I said last week, when you look at biodiversity, how many different species exist in ecosystem, the higher the diversity, that is an indication of high quality of an ecosystem. If the ecological system is poor or polluted, many of the organisms will die, and then others become more populated. So when you see high population and less diversity, that's an indication of low quality of water. And this has now been used a lot to actually evaluate aquatic system by looking at the biodiversity of material from that. And you can do that with the light microscope or electron microscope. And we do have this capability. This is actually done in TSU. Everything you see in this slide were done by us. It's our work. And I collaborated with Dr. Wilson and some other faculty member that they no longer in TSU, and we published several papers. Now, human exposure